Now, when flying, do you dread that illuminated seatbelt sign and that high-pitched ping signalling that it could be a bumpy journey? Turbulence usually passes on flights, inflicting no more than mild discomfort. But as we saw a few weeks ago at Shannon Airport, it can cause serious problems as well. And unfortunately, according to climate scientists, it's going to become a lot worse. Let's talk to Dr. Paul Williams from the University of Reading. Good morning to you, Dr. Williams.
Good morning, Elaine.
I have to preface this interview with admitting that I cried on the way home from my honeymoon because the turbulence got so bad, and you're telling me it's getting worse.
Oh no! Well, actually, you're not alone in that fact, because we know that perhaps 20 to 30% of people are afraid of flying. And I would think that turbulence would be one of the main causes of those fears. So there's plenty of people who are scared, just like you were on that flight.
Oh, I'm terrible with it. But what exactly causes it, and why is it going to get worse?
Yeah, that's the million-dollar question. So there's a couple of links in the chain, really, but what it boils down to is it's the carbon dioxide emissions that we're putting into the atmosphere from our industrial activities. Those emissions are changing the temperature patterns. That's widely accepted. But interestingly, it's not just happening at ground level. The climate is changing high up in the atmosphere too, all the way up to 35,000 feet. And those temperature changes at flight levels are changing the atmospheric winds. And I'm talking now about the jet stream winds, increasing the jet stream winds. And it's instabilities within the jet stream winds that cause clear air turbulence to break out. So in a nutshell, that's how we get from CO2 to clear air turbulence. The CO2 changes the temperatures change the winds, and the winds increase the turbulence.
What's your worst turbulence experience?
Oh, I had a bad one just a couple of weeks ago.
Did you?
Yes, over the mid-Atlantic. It's the worst turbulence I've experienced in my life, really, I think, and it just went on for, well, it felt like an hour or two. That was pretty strong turbulence.
Did you cry?
Do I have to answer that? No, I didn't cry, but even as someone who works on turbulence and understands that it's very safe, actually, really, there is a part of your brain, the subconscious part of your brain, that thinks, hang on, what's going on here? This isn't normal, is it? And am I safe? Of course we are safe, but there's a bit of the brain that does question that.
Is there any technology being developed that can minimise the impact on passengers, or is turbulence just something we're going to have to deal with?
Well, funnily enough, there is some very experimental technology at this stage, which involves shining, believe it or not, an ultraviolet laser out of the front of the plane and looking at the reflected light that comes back. Now, it is claimed that by analysing the reflected ultraviolet light, it's possible to detect density perturbations ahead of a plane that are indicative of turbulence. I've seen some initial results from trials that they've done, and this technology does look very good. Unfortunately, it is expensive, and that's partly why we're not seeing it rolled out on fleets of aircraft at the moment. But as the price comes down, and especially if there's more turbulence going to be happening in the future, we might well see this turbulence rolled out. And it does have at least in theory, could make turbulence encounters a thing of the past, really. The initial results I've seen are very impressive, so it really does work.
OK, I'll take that. Thanks so much for joining us this morning. Dr. Paul Williams there from the University of Reading.